In this lesson, we will examine how to avoid common mistakes that students make when tackling data sufficiency questions. The first tip is, do not assume that numbers are integers. For example, in this question, we want to find the value of x. Statement 1 tells us that x is less than 5, so it is not sufficient. Statement 2 tells us that x is greater than 3, so it is not sufficient. Now, if we combine the statements, we see that x is greater than 3 and less than 5. If we assume that x is an integer, we will conclude that x must equal 4, in which case the combined statements would be sufficient. However, there is no reason to assume that x is an integer, since there is no mention of this in the question. So x can be any number greater than 3 and less than 5. Since we cannot definitively determine the value of x, the combined statements are not sufficient, which means the correct answer is E. The next tip is, do not assume that numbers are not integers. For example, in this question, we have a class of students, and we want to determine the number of boys in the class. Statement 1 tells us that there are fewer than 20 students in the class. This certainly does not provide enough information to determine the number of boys, so this statement is not sufficient. Statement 2 tells us that 10% of the students are boys. Since we don't know the total number of students, there is no way to determine the number of boys, so statement 2 is not sufficient. Now, if we combine the two statements, we know that the total number of students is less than 20, and we know that 10% of the students are boys. At this point, we might conclude that since we still do not know the total number of students, there is no way to determine the number of boys. If we make this conclusion, then we will conclude that the combined statements are not sufficient, and the answer is E. This answer, however, is incorrect. Let's see why. Since there are fewer than 20 students, it is possible that there are 19 students altogether. Since 10% of the students are boys, this would mean that the number of boys will equal 10% of 19, which is 1.9. Now, of course, we can't have 1.9 boys, so this is not the correct answer. Perhaps there are 18 students in total. Well, that would mean that there are 1.8 boys, which still cannot be the answer. Since this is a real-world question, the number of boys must be a positive integer. If we continue to test various values for the total number of students, we will find that when there are 10 students, the total number of boys is 1. For all other possible values for the total number of students, we will find that the number of boys will be non-integers. So if we recognize that the number of boys must be a positive integer, then the total number of students must be 10, and the number of boys must be 1. Since the statements combined yield only one possible answer to the target question, they are sufficient, which means the correct answer is C. Now, the next tip is related to the last example. It is, do not assume that numbers can be negative. Now, in this question, we want to find the value of x. Statement 1 tells us that x squared is equal to 400. If we solve this equation for x, we see that x can equal 20 or negative 20, which means our statement is not sufficient. Now compare this question to this one. In this question, we want to find Petra's age. Statement 1 tells us that Petra's age squared is equal to 400. So if we let p equal Petra's age, then we can write the equation p squared equals 400. When we solve this equation for p, we see that p can equal 20 or negative 20. So we might conclude that statement 1 is not sufficient. Of course, this would be incorrect, since Petra's age cannot be a negative number. So once we remove negative 20 from the possible values of p, we can see that p must equal 20, which means that statement 1 is sufficient. So to summarize, you can avoid common errors if you do not assume that numbers are integers, and if you watch out for real-world questions where positive integers are implied.